I'm going to give you guys some preliminary data. Can you guys see if it shows that it's recording on your screens? Okay, it is. I've only have 3 left to read. 3, and everybody that's turned them in this period, I've received. I'm not going to go to the chat today, except for right now. If you have not received feedback from me, I need to know, because maybe you've turned in one after I left first period. If you've not received comments from me and you've turned one in, I need to know to add you to go. I need to go back. So 1, pay attention to my feedback. It is going to be extremely important that you do so. I have given comments to every single solitary paper. Save the submission after I have comments. So what I mean, after I provide these comments, I need you to make a copy and save it in your Google Drive, because guys, next year, we're not going to be on Schoology. We're not going to be on Schoology. It's just, you need to save it. If not, you lose it and you're kind of starting from zero. You don't want to start from zero there. Do not start until August, because I have some equipment that many of you guys probably are going to want to use. So don't start until August. That's just going to be really important that you guys wait that long. I'm going to give you guys feedback. You can kind of marinate over that over the summer and have a really clear idea of what to do. As soon as we get back, you can start beginning your IAs. There's going to be limited lab space. Some of you guys are, I can tell a lot of you guys are going to be using the lab. You're going to have to partition that lab for you. And so different lab stations are going to be used for different people. You may be running a lot of experiments in here when we come back. But you need to talk to me about that, because I need to make sure that we're going to be doing experiments in here as well. Thank God. It is okay if you make more changes as you see fit, but this is an important point. I can't offer any more feedback after you turn in your revisions. Your revisions are going to be turned in on the 10th of next month. And after that, I cannot give you any more feedback. So if you do, and this is probably going to happen for probably 30 to 40% of you guys are going to say, you know what? I'm going to do something different. And if you do, knock yourself out, but you're going to have to do you're going to have to take that feedback that I gave you on that first experiment and see how it applies to the other. It's going to be important that you really kind of pay attention and know what you're doing when you do that. I can only offer you that feedback. I'm not even supposed to be offering you guys feedback like I am. I'm supposed to have a 10-minute conversation with you, literally word, and you would take notes of that conversation. That's all I'm supposed to do. So I'm giving you 2 rounds of feedback, and then after that, I'm backing off because I've already overexceeded myself. Consider asking others for their proposals. This is super duper important. Consider asking others for their proposals to get additional ideas on revisions. The reason I say this is that, guys, no one can plagiarize your work. And you also should be consider lending it and not being, like, oh no, I'm gonna hold on to this. This is all my good. You should share. You want to be kind to one another, right? There's a reason that we call them learning communities. We should be helping one another. So if I give you ideas and comments or feedback on your experiment, you may not have written enough that I could give you a ton of feedback, right? But if somebody else did do even more, then you could help, you could get some ideas from their feedback as well, and also just kind of get some ideas. It is okay with being uncomfortable. If you're never uncomfortable, you can't grow. If you want to stay in a cocoon and be comfortable where you are, you're not going to ever get any better at life. Getting better at life is putting yourself at risk and then negotiating that risk. And if you can negotiate that risk, you get better. So that's important information for you guys. Proposals also. The revised proposal is a summative grade. That's going to be that next revision that you turn in. I'm going to score it. I have taken the expiration phase, that the rubric is attached to that folder. I'm looking at just the expiration. So I'm literally took that and just broke it down really fine so that you're not overlooking anything. So I'm going to use that part of the rubric to assess you. This has to be a biological experiment. There are 4 people that have turned in experiments that are not biological. They're testing something other than biology. You cannot do that. You can't. If you want to twist it or spin it somehow, like there's somebody who's looking at generation of power, they're spinning that with renewable energies. They're spinning that towards climate change. So if you can make that case, awesome. Otherwise, you can't do it, right? Boiling water, those kinds of things are not going to cut it. So it has to be a lot of biological experiments, a biology class. Anyone who has not submitted a proposal by tomorrow will get a phone call by tomorrow. I will be calling families starting tomorrow and on Friday till I get everybody. There's only 17 of you that have not turned those in. I'm hoping that there'll be more of those today. And then after school tomorrow, I'll start calling your parents, and I'll keep calling until I get a hold of somebody. So it's important that you guys get these turned in. Strongly consider these topics. Now, pay really close attention. And this is important because these are easy and they're tested. Photosynthesis. Holy crap, that's not a hard one to do. It's not the easiest one to do, but it's not hard either. If you have some protocols, if you want a protocol for testing hypothesis, send me an email. Hey, actually, call me first. Everybody here has my phone number. I've sent it 1,000 times in emails. If you don't, you can send me a message on Remind. And so I know I will send you an email with the protocol for meaning procedure for photosynthesis. Change it a little bit. That's all you got to do. Phototropism. This is probably one of the easiest ones to do. This is not hard. Look into that topic and you can find a million experiments for that. Transpiration, super straightforward, easy. You can do it in a day and never have to worry about it again. Not a hard experiment to do. Literally take a day. Enzymatic reactions, same thing. It's a little more complicated because you have to deal with a lot of reactions, but you can do it in a day. It's not hard. Diffusion and osmosis, also super straightforward, super simple. It is tested and you can get all the data you need done in a day. If you are here, you need to speak. Caleb, you have something you need to say? You had something you need to say? You put a number 4 in the chat box?
Oh, why?
There's an accident?
Yeah.
Okay. Respiration is also a relatively easy one, but it's like photosynthesis. It's a little more difficult. These in the middle, these sandwiches, those are the easiest to do. All right, I am moving. Common problems. These are things I have seen from your feedback so far. Your sample sizes are too small. You're going to have to increase sample size. You need 20 trials per group. People that are running 4 or 5 trials in a group are not going to be okay. You need enough data that we can run statistics over it. Needs to be at least 20 per group. So if you have graduations of, say, temperature of 20, 30, 40, 50 degrees, that's 4 groups, you need 80 trials. So you'll have 80 points of data. They're not controlled very well, guys. You guys need to work on your control variables. This is a common mistake that kids make, and I saw a lot of people getting marks off from the moderators. You have to control your experiments and make sure the only change is going to be an independent variable. There's some of you guys that never put a control group in there. I didn't ask what your control group was. I just kind of assumed that you would put one, and I guess that's something I shouldn't have assumed. You need a control group. Without a control group, what are we doing? I mean, what are you doing? You got to have something to compare it to. This is a real issue. So control groups are going to be important. And then there's no real clear method for measuring your dependent variable. Looking at something, okay, or you're saying, I'm gonna take data. How are you gonna take data? How are you gonna do that? I mean, you have to describe how you're gonna collect that dependent variable. If you go into an experiment and you don't know how you're actually gonna collect that dependent variable's data, you're gonna get there, you're gonna go like, oh my God, I'm not ready. You have to have a method for doing this. All right, that's it. I recorded this. This is at the beginning of the lesson, so if you need to come back and check it out, you can. I'll post the recording after class today. So today, you guys do have a really easy lesson. This is actually no different than how I teach it to the freshmen. It really isn't, and including the working on the power terms. And today has a special emphasis on power terms. So I'm going to stop sharing for just a second. I'm going to go to Schoology. And I'm literally going to have you guys like a baby. I'm going to have you read to me what the point of today's lesson is. So give me just a sec. Let me go to Schoology. Come on, you silly thing. Schoology. There we go. Beautiful. I want you guys to read to me today's, what are we doing today? There is an agenda. And so let's say the most beautiful child in the room, read it to me. Read just the introduction to new material. That's what I really want you to tell me.
Students will take notes on similar selection pressures on organisms, produce similar phenotypes, and how reciprocal selection pressures placed on organisms reinforce phenotypes. Special emphasis will be placed on power terms.
Yes. Hello, beautiful children of Earth. Is it working now?
Yeah.
Hello? Holy crap, y'all couldn't hear me. Sorry. When we get to the independent practice, guys, you're going to present today. There'll be 4 people in a group. One person will be called upon. You will not know who that person is. If they do not speak, if they do not present, then they will be taken out of that group and they can submit independently. So you do have a grade today, but it's going to be hinging upon your idea of making sure that you know these power terms and that you do pay attention. So pay close attention. I'm going to put a lot on you guys. I want to make sure that you guys are ready to go. None of this Mickey Mouse stuff. All right, so today, you want to take these notes. So if you're not prepared to take notes, you're going to have a very difficult time for this. So I'm going to pause for a moment and I'm going to let you guys get what you need for your notes. Diego, you need something to take notes with. Do you need a pen or pencil? There's pens behind you. Hopefully you got some paper in your bag. I'm going to pause for a minute. The more I have to pause, you hear, this includes you. Oh, you got it there. Okay. If you're taking notes on your computer, I'm down with that too. Okay, so coevolution, there's a particularly important word here. This is going to be reciprocal. This is the word reciprocal is going to be the word that we're going to focus on. Reciprocal pressures are going to be pressures back and forth. So if I'm organism A and there's another organism B, they're both putting pressure on each other. So this is reciprocal pressure. You could think of it like me. This is teacher and this is student. We're not experiencing the same selection pressures, but we're putting pressure on each other. You are turning in work. That makes me stay up late. So I'm staying up late at night. I stay up late. And then you are also, I'm putting pressure on you. Your job is to learn, but I don't know whether you've learned unless I come back and read and give you feedback, right? So we're putting different pressures on each other. One is to learn and one is to assess. One is to teach and one is to think. Is probably thinking on both, but it's reciprocal, meaning that it's putting pressure back and forth, back and forth. I also look, the average student at your age should be able to write 20 words a minute. There are 16 words here. So when I pause on these terms, if you need to write this term or write this definition or write this idea, then being here for 1 minute is plenty of time. I've lingered here longer than that. And then also it is used to describe, and we're going to focus on power terms. One of them is describe. So let me give you some examples. First one is going to be a swallowtail. Swallowtail is a butterfly, mariposa, and the fringed hue is a plant. The fringed hue is here. This is the plant. The swallowtail is right here. This is the caterpillar. And they put a lot of pressure on each other. They co-evolve. This caterpillar eats a fringed hue. A fringed hue is extremely toxic. If you were to try to eat it, it'd make you sick. You probably wouldn't even try to eat it. You'd taste it, you'd spit it out because it's extremely bitter and tastes foul. Well, the caterpillar can eat it. It has a set of enzymes that can break it down. But if it eats it, it hurts the fitness of the tree because the tree doesn't live. If the tree doesn't live, it doesn't reproduce. If it doesn't reproduce, its fitness decreases. So the only ones that live are the ones that can resist the caterpillars. Well, the caterpillars, the only ones that live, can resist the fringed hues toxins. So it's like an arms race. You can think of it like, let's say this is you guys are in history now. Y'all probably haven't got to the Cold War yet, but if this is the USSR, which was the former Soviet Republic, and this is the USA, they had nuclear weapons facing each other that would destroy the other one. Well, if the USSR built a weapon that was better than the United States built another weapon that was better than USSR. And they kept getting stronger and stronger and stronger. And it was an arms race. It was an arms race. You could think of it just like in any case. You know, if you have two competing businesses that are going to get stronger, put reciprocal pressure on each other, how you would actually write that. And so the next quiz you guys have, no quiz today, is going to be open answer. You're going to have to write, and you're going to have to write about two things, coevolution and convergent. So I'll give you a scenario, and you're going to have to write about it. This is how I would write this. I'm going to pause for about a minute, and then I want you guys to ask me questions about what you don't understand here. Special emphasis on speaking today. This is how I would write that if it were me. Remember, a description is basically telling me how it happens. Think of it as how it happens. Description equals how. No. So one person, there are 4 people on here that I know cannot talk. One of the persons that did just ask a question said, I know that their mic doesn't work. They may not give you an image. No, they could just give you a scenario. And then you would have to be able to break it down. It could literally be written. Maybe they'll give you an image and maybe they won't. It can go both ways. They could give you a graph too. We're going to look at a graph in a minute. So here is a graph to kind of give you an example. Would you guys consider this to be a positive or negative correlation? Is this positive or a negative correlation? What kind of correlation is this? It is. It's a positive correlation. You can see it's a positive correlation. So in this case, this garter snake, as this snake gets more resistant to toxins, the salamander gets more venomous or more toxic. So that's what you've got to do. Yeah, it's basically affecting, it's reciprocal pressure. As the snake gets more resistant, the salamander gets more toxic. As the salamander gets more toxic, the surviving snakes have to get more resistant. And it's just an arms race. It goes one direction. It goes one direction over and over and over. It's like a positive feedback loop. Let's take a look. We've got 2 graphs here. Now let me, does anything here strike you as being really weird? Look at the data. Look at the graph. These are the sites. that show venom in squirrels. These are rattlesnakes and squirrels. Does anything here strike you as being odd? Special emphasis on speaking. If I know your mic works, yeah, it's positive and negative. There's one person I know, they're the same person that doesn't have a mic.
So wait, why would elevation affect how venomous a snake is?
Yeah, it's a good question. It's a good question. Do you also notice that with elevation, what happens to squirrel resistance?
It decreases.
Yeah, it decreases. It totally decreases, right? As I get a higher elevation, I get less resistance. But the snakes at higher elevations are more toxic. That's really weird. So that begs the question, right? So whenever I saw this graph, I think that was Keaton that brought that point up, and I saw this graph on a paper. I thought, man, I need to read this. This is cool. And I did, and it was amazing. Let me explain to you what happens. So think about a mountain. A mountain is going to be very what? At the top of a mountain, what is it like at the top of the mountain versus the lower part of the mountain? What is the environment like at the tops of mountains? It is colder. You're correct, sir. So are snakes warm-blooded or cold-blooded?
They're cold-blooded.
Yeah, they're cold-blooded. They are. They're cold-blooded. So snakes, these snakes that at higher elevations are very, 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 they're in low density. There's not very many of them. The reason is it's too cold. They can't live there, not very easily. So if it's cold, if it's cooler, and you're a snake living there and you kill a squirrel, you can't just go out and get, a squirrel. If you bite a squirrel, let's say this is where you bite the squirrel's going to run. This is where the bite occurred. The squirrel's going to run, and then the squirrel's going to die here. The squirrel took the dirt nap right here. It's going to die. Goodbye, squirrel. This is where the squirrel dies. That's supposed to be my dead squirrel. Well, the snake has got to crawl over there and eat it. If it's cold, it can't crawl very far because they're cold-blooded. They're going to be ectotherms. They can't do it. So they need to make sure when they bite the squirrel, let's say this is the bite, they run and die right there. The squirrel is dead really quick. This is my dead squirrel. It dies fast. If the squirrel doesn't go very far and then it dies, the snake doesn't have to go very far to eat it. Now, at lower elevations, there's a bunch of squirrels, tons of squirrels. You don't have to be very toxic to get one, right? There you have a lot of opportunities. The other thing is these snakes are in really low densities, and when it's very high in the mountains, there's a lot of snakes at the lower elevations, very few snakes here. So if there's very few snakes here, and let's look at this, the squirrel, there's very few snakes, and there's a lot, by the way, is 2 words. I just want to go ahead and say that to you guys. I didn't mean to start breakout rooms.
Never mind.
What? Yeah, I know it. So if there's a lot of snakes here, the selection pressure is really high. I got high selection. If it's low, there's very few snakes, you got a very low selection. So squirrel resistance is low. Here, the pressure is different. So this is going to be, there's few squirrels, and it's cold. Or maybe I should say not cool, but cold. Here, there's a lot of squirrels, and it's warm. So you got a lot of opportunities to get a squirrel, and if you kill one, you can crawl around and go find it. No big deal. Here, you don't have as many squirrels, and it's cold. So if you kill one, you better kill it because you won't get an opportunity again, and it's going to be cold. You can't go crawl around and look at it. Now, how would I write that? Well, first, I want to talk about why that works. One of you guys is doing an enzyme experiment. I think you're a little fuzzy on an enzyme. So this is going to be inside of the snake. So this is going to be this, or inside the squirrel. Okay, 5 minutes. So inside of the squirrel, I have an enzyme that breaks down the venom. So this would be the venom, and this would be the enzyme that breaks down that venom. So the venom, you get bitten by a snake, the squirrel can break down that venom and break it into 2 products where it's no longer a problem. Remember, that's how enzymes work. They have an active site. This is how I would write it. Take a look. This is an explanation. So an explanation isn't how, it is what. What would the word be instead of an explanation? It would be, instead of how, it would be what? Thank you. I'm trying to get somebody, I'm looking for people to speak. There's a lot of you guys in the chat that are saying. Instead of how, it is what?
Why?
There you go. You guys, it's going to be important that you speak because I need to get through to give you guys a chance to practice. It's why. And this is how I would write that if that were open response. An explanation is a reason. It is why something is happening. That's going to be the difference. Okay, now let's go to another quick little example. As you can see here, it's pretty cool. This is also coevolution. It's reciprocal pressure, right? So what's the selection pressure on the flower? I've got a fly. This is actually a fly. The fly has a mouth. This is its mouth part here. This is a proboscis. Yes, I'm not actually sure. How do I spell it? Proboscis. I think that's it. Proboscis. This is the proboscis. This is where it drinks, right? It's getting food here. It drinks here at the very end. This is like a long mouth. There's nectar here at the very end of this nectar tube. So there's nectar here. There's food at the bottom of this shaft. Here there's pollen on the flower. And here's the pollen that gets collected on the fly. So the selection pressure on the flower is to find food. The selection the selection pressure on the plant is for reproduction. Reproduction. The selection pressure on the animal, on the fly, is to get food. If this nectar tube is getting longer, it forces the proboscis, the ones that survive have longer proboscis. And if it is a longer nectar tube, then it's going to get that fly to hang around and get more pollen to take it to another plant. And pollination occurs, so I get reproduction for the benefit of one, food for the benefit of the other. This is how I would write that. I'll linger here, let you read this. Another example, same thing. Another example, the very same thing. No, they'll give you something, and sometimes they'll have prior knowledge. So yes, there's a good question. So somebody asked, will they give you a scenario? Always. Sometimes they will. Sometimes they'll just say, give me an example of coevolution, and you could use. And if it were me, hummingbirds and plants would work. You could also say, and the same thing here. So the selection pressure is the very same. The selection pressure on the moth is going to be food. The selection pressure on the flower is going to be reproduction. Pretty easy. That's it. And so this long, this proboscis, you can see probably extends way down here. And there's the anther that has the pollen is right there. The wingtips touch it. Same thing here. The proboscis is ridiculously long. It goes all the way down this nectar tube. Goes all the way down this nectar tube, and it collects pollen. So you could use lots of examples. There's a ton of them, and you're going to find some more in a little while. All right, next is going to be different. Convergent evolution. What does it mean to converge? I've got 3.5 minutes. What does it mean to converge? I don't know about change. No. What does it mean to converge? Thank you for trying. I'm looking for people to speak.
Is it come together or to
Come together. That's right. It means come together. To converge means to come together. That's right. That means to come together. To converge is to come together. So two cars crash into each other, converge. They come into the same point. So you can think of this as these are two lanes of traffic, and so they're coming to the same point. That is convergence. So this means that you're going to have similar characteristics, right? And I'm pausing here for a moment so you guys to actually take notes. I've seen 3 people in this class take notes during this time. This is a definition that you're going to need in a moment. This is not television, guys. This is where you have to learn, and to learn is to write, to light is to remember is to get better. And so there is going to be these two, and these organisms are not closely related, right? They're not even in the same areas most of the time, but they have similar selection pressures because they come from similar environments. So they're converging to the same conclusion. They're coming to the same conclusion. And that's what convergence is. And again, if you need to come back and reference this PowerPoint when you go to the guided practice, you can. So I'm going to give you some examples. A placental mammal is going to be us. We have a uterus, and we give birth to fully developed offspring. Marsupials do not. They have pouches. They are not distantly, they are not closely related. Marsupials, a classic is going to be the kangaroo. There's only one marsupial left in North America, and that's the possum. Yet these have similar selection pressures, very similar selection pressures. So these are going to be squirrels. It's a flying phalanger. They have very similar lifestyles. They live in trees. They glide from one tree to the next. This is a groundhog here. This is a wombat. They live in the same habitats. Here you can see they have an anteater, South American anteater and an Australian anteater. This is a mole, a North American mole. This is the Australian mole. It literally looks almost exactly the same, but they're not closely related. They both have similar selection pressures. They even have a marsupial mouse. It's like a friggin' kangaroo mouse. It has a pouch, not closely related. They have the same selection pressures. They live in the same areas doing the same things. And so selection has acted on those traits for them to be very, very similar. It's incredible. What do you think the selection pressures are on these? You guys practice in a minute and 30 seconds. I need you to talk. What do you think the selection pressures that maintain these traits? Going, remember, there's generated and maintained. There's no, not generated, but maintained. Selection pressures don't cause traits, they maintain them. I'm sorry? They all have long noses. Why? There's a point. Okay. Exactly. Good. So we got 1 more minute. So yes, the prey is small. So they have to poke their nose into small places. So the ones that had smallest noses were able to get in those small places. The ones that had got their nose into small places were able to survive, pass down that trait. What else do you notice that they all possess? What other selection pressures? I'm going to take time off your guided practice, not time off this, if I have to start taking time off. They're in different regions, but phenotypically. I'm sorry? They all have long claws for what? Okay, tearing down something. Yes, they'd have long claws for tearing into, in this case, insect mounds or the dirt to get insects. One other thing, what else do you notice? They all have something else. If your head's in the dirt poking around for insects, what do you think the problem's going to be?
They have their eyes on the side of their heads. Their eyes on the
yeah, that's a good point. They have the eyes on the side of their heads, so maybe they don't get their eyes in dirt and they can look out for predators back and forth. But they also have these scaly, very squilly backs to protect them from predators, but while their heads are down. So the ones that had these traits lived. They all experienced the same selection pressures, therefore evolution guided them to come to the same conclusion. What about here? By the way, what is this? Is this a fish, mammal, reptile? What is this? It's a mammal. That's right. This is a mammal. It's a dolphin. What about this? No, it's not. It's not a shark. Oh, no. It's not a fish. It's an ichthyosaur. Yeah. So what is an ichthyosaur? Yeah, well, not a dinosaur, an ichthyosaur. It was a reptile that lived in the ocean, but it was a reptile. What is this? A fish. What is this? A what? I know it's a penguin, but what is a penguin? They, they lay eggs. That's right. So they're not mammals. There are some mammals that can lay eggs, but there's two. I'm not going to chat. Somebody's gonna have to talk. I'm cutting time off y'all's guided practice. What is this? Somebody else better speak other than the kids in this class. We're stuck, guys.
Marsupial.
It's not a marsupial.
Would you call it a bird?
Oh, it's
Yeah,
a
there
bird.
you go.
That's right. There you go. Penguins are birds. Oh, yeah. Okay, it's a bird. They all have the same traits. Well, the question becomes why? They're convergent. They all have the same. So here's my explanation. This is why. This is why. And you'll get to practice in just a second. You need to read that. Not look at the ceiling, read that. You're going to do it in a minute. Pretty cool, huh? They all needed to find food in the water. Now, I'm sure there was a lot of organisms that didn't have traits that allowed that. Some of these had some traits that could be maintained. It doesn't mean that the environment caused these traits. It just means the existing traits that they had could be modified because they already had those traits in the first place. The ones that had that did it best survived, and they got progressively more torpedo shaped, longer snouts to be able to snatch more prey more effectively. This is it. Okay, I am going to stop for a second. Now I'm going to go to Schoology. I should see everybody piled onto Schoology in just a moment. You should be there. Let's get to Schoology. I'm opening this document. Just a guided practice. As soon as I get 10 people on this document, I'm going to start. Walk around. Get to the guided practice document. All right. Okie dokie, Finokis. Here's how it's going to work. We've got 10 there. So let me point a couple things out and then I'll break you into your groups. We're going to have, in this case, we're going to have a little less time. Right now, we're only going to have 16 minutes if we started right now. So probably 15 minutes that you're in here. There's going to be a group. When you find your group, you put your group names in there. Identify the selection pressure on both. You could have coevolution, or you could have convergent evolution. All you got to do is identify the selection pressure. Convergent is the same selection pressures. Coevolution is the same selection pressures. There's two. And identify, again, coevolution has different selection pressures they're putting on each organism. So you'll have to have two selection pressures acting on the trait of both organisms. It's coevolution. And describing how the traits increase the fitness of the organism. So you're going to have to go back to the idea of fitness. Fitness is going to be described as the ability of an organism to survive and then pass down their traits to offspring, have offspring that survive themselves to reproduce. Now, when you get in here, it would be my strong recommendation that as soon as you get in here, you guys talk. You're going to have to find an example online. There's a million of them. And then you're going to have different sections filled in by different people. You'll be in groups of 4. Make sure you check over each other's work. And let's see, at 9:25, I'm bringing you guys back and you're presenting. So keep up with the time. Then we'll have 5 minutes to present it. You'll have less than 5 minutes. You're going to have to present fast. You're gonna have to present fast or I'll bring you back early. One or the other. One or the other. That's it. So next class we have, we're gonna do it again. You're gonna have to talk. You're gonna have to talk. If I have to go to the chat, it cuts down on time. If it cuts down on time, we get to cut down on practice. I can't stop me having to deliver what I need to deliver. So here you go. You're actually gonna have 14 minutes now. There are 8 groups. If somebody is not working in your group, send me a message. I'll take them out and put them in a different group. I'll put them in a different group. All right, go. Mhm. Abel, you in group 8, or yeah, there's 3 groups that only have 3 people. They want what? If you guys are going to chat back and forth, you're going to lose time and it's going to suck. I don't think we want to call anybody tonight. Ooh, that went fast. Whose group is that? What? Oh, never mind, sorry. Hmm? It's 10 minutes. Yeah, there's a ton. Hummingbirds is a good example. What group are you guys with that? Oh, it's talking to D, okay. Y'all group 1, okay. So y'all got coevolution. Yeah, that's a. I don't know about that picture. Is that for hummingbirds? And hummingbirds and plants? Hmm. Go a lot faster if you guys talk. Hmm? Nice. Ha! Group 2 figured out how to spell proboscis. They used my example, I misspelled it. Oh, that's funny. You guys are doing pretty good. There's a lot. There's lots of cool examples. Wait till you see the hook for the next class. You're going to be like, what? The mutualism is the ecological version of it. You can use it. You just have to flip it to coevolution. There's no doubt. That's a good point. You found something that I'm going to bring into the next unit. It's a really good point. What the hell? No, y'all good. Yeah, there's some, looks like you guys are going to be able to finish most of it, everybody, 5 minutes. If you guys are done, are y'all confident in your answers? So like, for example, on yours, what group are you in, kiddo? You're in which one? 3? So let's go take a look at 3. Pressures are acting on the trait. Okay, but what's the pressure on the bird? What's the pressure on the bird? Okay, so it says the mimic butterfly evolves its appearance to the monarch butterfly because the monarch is inedible to the bird. This allows the mimic butterfly to avoid predators. But what is the butterfly having to do? Coming down more easily identify the one that's edible. So then what I would need you to do is describe how that selection pressure is acting on the bird. So is it just, how is that acting on the bird? The bird's having to be more discriminatory or something. Be able to really pay attention to which is which. The mind differentiates itself, so get back the Berman. Okay, you guys did a boss job on the description. You just needed to identify that selection pressure on the bird too. Yeah, that's the only point that I would say. So really look at it, make sure you're hitting all of it. So like on the top right corner, it says identify how the selection pressures are acting on the trait. So the trait for the bird is going to be discrimination, right? The bird's going to have to discriminate against one or the other. But really take a look at it. Is everybody working with y'all in y'all's rooms?
Yeah, except for
She didn't say a word to you guys?
she came in and she was typing something. But
She
she erased what she did.
is she gone?
Yeah.
Like
It's not in the PowerPoint thing. Not sure.
she can hear you talking? That's good. You guys put pressure on each other. You should have coevolution, right? Coevolution. I put pressure on you, put pressure on me. That's what it's together. I don't know if it should be convergent. It could be a combination of convergence and not. Wait a minute, what? 4 and 4. Beautiful children of earth. Yeah, let me see. Hold on a second while I'm waiting for everybody to come in. You did not take the quiz from last class. I don't think, unless you took it since then. And you hadn't for the last 2 classes. I don't think. I'm trying to get to. Good morning, beautiful children. You guys are making your way. Let's see. Yep, you got the last 2. You need to hit those. All right, so what are you guys all back? You are. Oh, welcome back, kiddos. All right, there's not any I think Randy was right. There's no way to have you guys present this time. It would just be rushing. And if I rush, you're not going to get the point. And if you don't get the point, what's the point, right? You guys did really well though. So when we do come back, we're going to finish the next lesson is going to be even faster. It's really quick and easy. You guys did a really good job on this. I'm going to just look at the very first one. Okay. So this is group 1, Landry, Caleb, Diego. So identify the selection pressures on both. So the acacia ants provide protection for the acacia plant, while the acacia provides the ant with shelter. So shelter for ants, protection for the tree. Okay, selection pressures. Okay, so you got that. Identify how the selection pressures are acting on the trait. The acacia ants are able to protect the acacia. Identify how the selection pressure are acting on what trait. So what is the trait? So you wouldn't get this point. So I don't know what the trait is on that ant. What is that trait that ant has? There's no trait listed. There's also no trait on the plant. So this would be 25 points off. I just want to make sure everybody's hearing this so that you know when we come back. So they got 25 only. And there's no trait here, and there's only one trait listed, and there's 2 selection pressures. So the trait on the plant and the trait of the ant, that's missing. So you guys need to fix that. Picture makes sense. Describe how the traits increase the fitness. The ant helps the acacia compete against other plants for nutrients and sunlight, will help the plant give shelter to the larvae, increasing both of their fitnesses. That's okay. I like that. That means I might put something about their most of them, they'll survive more often. If they survive more often, they'll be able to reproduce more because they're living. You could make that better, but I think that would score marks on the test. I feel like that they would give you points for that. So this would be a 75. Just so you guys know, I'm gonna just give you guys a really quick look. All right, we're gonna split. I'm not gonna see you guys next class, guys. And hold on, I haven't taken attendance. Don't leave just yet. Next class, you're gonna have another one, and then we're gonna have it'll be completely open answer. There will be no way that you guys can cheat on this, right? It's 100% open answer. So you want to come back and take a look at this document, the notes, the video. You want to get really good marks on this next quiz. Really good marks on this next quiz. If you need to take the retake for Hardy-Weinberg, you'll notice I screwed it up on one of the questions. You can take the retake next Tuesday, All right, I've got attendance taken. You guys can split. You guys be good. Play in the street. I'll see some of you guys tomorrow.
Bye, Mr. Pope.
Bye, babies. Y'all be good. Bye-bye.
Moments of hope.
Oh, Mr. Pope, really quick question.
I'm got don't have to be quick. You can take as much time as you want. What's up?
Oh, all right. The IA proposal, I wasn't able to get feedback, but my partner was able to. So is that all
You
right?
didn't get feedback?
I mean, I looked on my IA proposal and I don't see like any
Okay,
comments on the
all
document.
right, cool. Thank you for saying that. So let's go and let's take a look at that document. Thank you for telling. I asked that question at the beginning of class. You may have come in late. IA proposal. Where's Yang? So open this. Okay, you're good. Thank you so much for telling me that. I knew I was going to overlook somebody. I overlooked you. Cool. Thank you. I made a note of it. I'll give you. You'll be the first to get feedback today.
Alrighty, thank you so much.
Thank you so much for telling me that. Awesome. Yes. Excellent. Yay. All right. Hey, what's up? How are you doing? What is your last name? Ibrahim. And who is your brother a sophomore? You're not related to him. Huh? It's Ardo's brother? Okay. How is Ramadan treating you? Are you celebrating Ramadan? Yeah. How is that treating you? How so?
I'm not as tired as I thought I would be. Not actually that tired.
I mean, right now we're at about 12 and a half hours of light and 11 and a half hours of night, right? Of darkness. So you just got to go 12 and a half hours. No. You had to speak up. Yeah, you got 18 hours of light and it's hot. It's fine. Do you lose any weight? So one thing, I know a lot of people pig out in the evening and pig out in the morning. Probably a bad idea. Just eat a normal amount. Yeah. So don't eat as much. It's probably a lot healthier just to live this way normally. Do you know humans they hypothesized that humans probably only ate earlier in our evolution probably once a day? There wasn't enough food around to eat that often. So they hypothesized that humans probably ate just in the evenings. They'd wake up in the mornings and hunt, gather, and then late in the evening would either hunt and gather right before bed or as soon as it got dark, eat and go to sleep. That was probably the normal rhythm for us. So this idea of eating 3-4 times a day is just all this processed food, gorging ourselves on all these carbohydrates and sweets. So like the selection pressure to be able to taste sweets was probably pretty high because if you're on the landscape and you taste something that's sweet, you're gonna be like, oh my God, I eat this, right? Fruit, and very rarely did you get it, right? Very rarely. Now we're just like, I just eat crap all day. Well, I'm glad. I wish I had had you guys. You guys seem like a good group of people, huh? You guys are a beautiful lot of people, that's for sure. You're welcome. Beautiful, beautiful people. I love it. Abuelito. I've got more rhymes than Jamaica's got abuelitos. I've got more rhymes than Jamaica's got abuelitos. Poems. Um, what was that? Did you get those vascular plants squared away, kid? Did you get those vascular plants squared away? Off into the wild.